Bismillahirrahmanirrahim. June 1842 variant and question number 7. And we have given mass A of the particle 1.6 and B is 2.4. And they connected with the same string. And rule of the topic, whenever we have a same string and we pull this way, so tension always same. It means this tension towards the pulley and this tension towards pulley always equal to each other. And naturally this is a mass B 2.4 into 10 24. So this downwards acting 24 newtons. It has component is a very clear, you know, this is 24 sine 30. Okay, because in part I no friction, so friction equal to 0, smooth. So that is why no tension here. And actually this is friction, but it is equal to 0. Okay, and although we have upward R, downward we know it into 10, I got 16 Newton, but because no friction, so if you don't make it these components, no issue. Okay, and I just make component all so you can understand. So this is R normally, okay, and this downward is a 24 cos 30. Again I say because friction is not there, so I will not involve this component. So let's start. System start from 0. So in the first I hold, for example I hold this one, I release, so it will move downward and it will move this way. So naturally clear this motion downwards here and this motion this way. So let's make a quick formula for B particle. So for B particle, the formula I'm writing here, net force equal to MA. Okay, so system is coming downward, so this force 2.24 sine 30 minus friction, but friction is not there, minus tension equal to MA. Mass is a 2.4A and this is coming 12. So I got one component is one equation is clear. Now for A I'm going to make equation, so system is going this way. So I can say that net force equal to MA. Okay, so tension minus friction equal to MA, but as friction is not there, so tension minus 0 and mass of this particle is 1.6 and times 2 acceleration. So I got 1. This is our number 2. This value of tension if I replace here, so put in 1. So what happens? 12 minus 1.6A equal to 2.4A. It goes there. So 2.4A plus 1.6A. So I got a 4A. So acceleration becomes sharp 3 meter per second square. So meter per second square. And this I put in 2. So put in 2. And I got tension 1.6 into 3. So for 4.8 Newton tension. So I think so. First part we got very easily and clearly. Now part number 2, he said no, friction is there. Okay, when friction is there, so what will happen now? I will make the components friction backward. So because system is now it has a friction. Okay. So what I will do now, if you read a question. So he asking us what here, I read a question. He said that mu and this surface, if horizontal is a rough, this is a rough surface and coefficient of the friction between A and the horizontal plane is 0.2. So we given here mu, so we can find easily F is equal to mu R. I talk about A. A on A. So F is equal to mu R, mu given 0.2 and R is 16. So I got a 3.2 Newton friction acting on A. Okay, this is very clear. Now he's saying the inclined plane is smooth. So here no friction. So this friction is not there. He mentioned clearly. So he's asking find total distance traveled by the A particle. So but problem, this tension and acceleration change in scenario number 2. So let's see how we can find, and 9-mark question we have to find distance traveled. Okay, so let's see how we can deal this question. But now I need acceleration. For look here, let's say it is moving this way. So starting speed 0, acceleration I can get by this technique, and I think so. And he mentioned here what to find distance traveled. Okay, so let's see. Bismillahirrahmanirrahim. So first I talk about this one. Okay, I think for equation for this will not change. So I will make equation B remain same. Reason, no friction, everything is same. Okay, so let's talk about this one. So I think so for B, part number 2. Part number 2 for B is remains same because friction is not there. So I will make the same equation. So 12 minus tension equal to 2.4A. Okay. Equation number 3. Okay. And what about this situation? You know, tension minus friction we have. So let's make for A. And net force equal to MA. Tension minus friction. So tension minus friction. Friction is 3.2. And MA is what we have, 1.6. Mass 1.6 A. Equation number 4. If I add them, tension cancel out of 12. So we can just check. Okay. So out of 12, subtract 3.2. And I got this one 8.8. And I got here 4. So divided by, we got 2.2. So acceleration is coming 2.2 meter per second square. Acceleration is clear now. This acceleration change, you see. First 3 now become 2.2. Okay. Now, what is problem we are facing here? He said find the total distance traveled by A. Actually, why 9-mark question? Okay, look, this is a 2.5 and here 1 meter. It means it will fall, it will go down when reach here, it will stop. It will stop. But it will move 1 meter, same distance, 1 meter, 1 meter. But it will not stop. Okay? I show you the plan for diagram or for the A particle. For the A particle situation, what we have, so I show you the idea behind. So it moves first 1 meter, right? So U0, acceleration throughout is 2.2, okay? When it moved to 1 meter. But for your knowledge, it will hit the floor and stop. It will hit the floor and stop. Due to the pull will finish. Why pull finish? Because it will hit the floor and stop. So the string become loose. Loose. So the force, this tension is behaving like a force. So tension will cut off automatically. Okay? And it will move due to inertia. How due to inertia? Like when you're pulling something, pushing, and release the pushing. So when release the pushing, it will not stop same time. It will go slightly forward and then stop. It means, so it will move in 2 stages. Stage 1 is from here to here, okay, and stage 2 is from here, and ultimately it becomes stop. Okay, so I just show you this is a stage number 2. Okay, this is stage, and ultimately it will stop here. So last speed is 0, but this will go due to inertia. I write here due to inertia. Okay. And this is until the particle will hit. Okay, this is the most important step here. Okay, here, what is my actual task? Distance traveled. This is 1 meter for sure. But if I get this distance, I will add and question finished. Right? Okay, but total distance 2.5. Maybe it will stop before 2.5. Naturally, it's not reaching pulling. Okay, so let's find. So, but one thing is interesting. You know what is interesting? What is moving and moving, what speed at this moment will become U for the next motion. Next motion, okay? So I will start. For this one, so let's talk about what is stage 1. For we can say step 1 or stage 1, no problem. Stage number 1, okay. Stage 1, what is the plan? So I need to find V. So V equal to 2AS equal to V square minus U square. 2 times to acceleration, I have 2.2, and S is 1 meter. Last speed is my question, U0. And answer is 2.2 into 2. So if I take a root of this answer, I got, I got a 4.4. And take the root of this answer, my x velocity is coming